Hi everyone, this is the bonus lecture for 61C review. This lecture is entirely optional and nothing on here will be tested directly on any exams, but all the topics in here will be required for the first unit of this course, which is memory safety. In the summer, this unit is going to be the first 2 weeks of the course. In the fall and spring, it's probably say the first 3 or 4 weeks of the course. In either case, this is the only part of the course that requires any 61C. Once you're out of the first section of the course, you really don't need any of this material anymore. But it's still good to review this stuff in case you haven't taken 61C or it's been a while since you've taken it and you don't feel fully comfortable with all of the topics. So let's jump in. In 161, we're going to look at the memory of C programs. And to do this, we need to know what kind of numbers we need to use to represent things at the very low levels. So in any program that you write, whether it's C or Java or Python, if you move all the way down to the lowest level of abstraction, you're going to have a whole lot of bits in memory. And each bit is just a binary digit, a 0 or a 1. Now, there are some units of measurement we've come up with that let us count how many bits there are. So this is the same as saying there are 100 centimeters in a meter, or saying there's 1,000 meters in a kilometer. In the same way we can say have those conversions, we have these conversions. So we have that 4 bits is equal to 1 nibble, we have 8 bits is equal to 1 byte, and we have 32 bits is equal to 1 word. And so this means that if I give you a long string of bits, so for example here I have a string of 16 bits, you can also say that this is 4 nibbles. You can also say that this is 2 bytes because there's 1 byte of 8 and then another byte of 8. You can also say that this is half a word because one word is 32 bits and we have 16 bits here, which is half of that. So we're going to have this at the bottom of the next couple slides so that you can convert between them if you have to. Okay, so writing out a whole bunch of bits sometimes gets kind of hard to read. So we do have this kind of shorthand, and the shorthand is going to let us write 1 nibble using 1 hexadecimal digit. So remember that hexadecimal is base 16. So that means that there are 16 different digits in hexadecimal. They range from 0 through 9 and then A through F. So the way to convert between these two is if I give you a whole bunch of binary digits, so a whole bunch of bits, the way to convert to hexadecimal is to take every group of 4 and then look up in this table what the corresponding hexadecimal is and then use that 1 digit instead. So this way, instead of writing a whole bunch of bits, I write a whole bunch of hexadecimal digits, and it's going to be a lot shorter, which is nice. So let's look at an example here. So here is some string of 16 bits, and because there are 16 bits, that means there are 4 nibbles, and so that means that each nibble is going to be written as 1 hexadecimal digit. So now we have 4 hexadecimal digits. And the way to do it is if you look at the red, that's the first nibble. The red is 1100. We look that up in the table, we get C. And then the same thing for the green, we get 1. And then the same thing for the blue, we get 6. And then the same thing for purple, we get 1. And so instead of writing this horrendous string of 16 bits, we've condensed it into just this very short hex string of 4 hexadecimal digits, which is nice. And just for clarity, we're going to write 0b in front of anything that's in binary. So these are bits. And anything that's hex, we're going to put a 0x in front of. So this is just so that if I give you a number like 11, you want to know is that 11 in binary or is that 11 in hexadecimal? We're going to use the 0b and the 0x to just make it very, very clear. So as a little exercise in converting between all these units, let's take a look at this slide. So remember that there are 8 bits in a byte, and that means that there are 2 nibbles in 1 byte. So that means that to write a byte, you need 2 hexadecimal digits. So examples of bytes are up here. We have 36, that's a byte. FF, that's also a byte. And remember that a word is 32 bits. 32 bits is the same as 8 nibbles. So that means that to write a word, you need to have 8 nibbles, and that's what we have here. So dead beef is a very common one you'll see, I guess just because it forms a word. So dead beef is DEADBEEF. That's 8 hexadecimal digits, and that's the same as 8 nibbles, which is 32 bits. So in this class, we're going to be mostly working with hexadecimal, but remember that why are we using hexadecimal? It's because under the hood, these are actually just long strings of bits, but we don't want to write out 32 bits. So instead, we're just going to write out a much shorter string of, like, say, 2 hexadecimal digits or 8 hexadecimal digits. As a quick aside, you might be wondering, why does this work? And to do this, you kind of have to go back to 61C, some of the very early lectures on number representation. But just very quickly, in case you were wondering, one hexadecimal digit has 16 possible values, right? 0 through 9 and A through F. And a nibble has 4 bits. Each bit has 2 possible values. So if you do the math, you get that one nibble can take on one of 16 possible values. And because the hexadecimal digit can take on 16 possible values, and the nibble can take on 16 possible values, I can just match them 1 to 1, and I get the table that I had on all the previous slides. Sometimes in this class, we're going to ask you to add and subtract hex numbers because we're using hex numbers so much. And sometimes we'll ask you to count in hex numbers. So in general, in this class, you're never going to have to do any of this stuff by hand. And in fact, we recommend that you don't because counting in hex is pretty hard and people make a lot of mistakes. So on project one of the most common mistakes is that people will do the hex math wrong and they'll be like, why is my code wrong? We'll all debug it for a long time and then we'll realize they just did the hex math wrong. So for this class, we definitely recommend if you ever need to do hex math, you should just pull up on Google, find the first hexadecimal calculator you can, and just do the math there. I think Google even lets you input hexadecimal directly, and it'll do the math for you. So always just let the calculator do the work. If we ever ask you a question on the exam, it'll be super easy hex math. You'll never, it's never going to be anything too complicated. But on the project, for sure, you should probably use a calculator just to be sure. Now, if we do ask you, if you don't want to pull out the calculator every time, I don't recommend it, but if you do want to learn how to count in hexadecimal, the most common thing we're going to be doing is counting by 4s. So in base 10, which is decimal, that's the base you always use, you can count by 5s, right? You can count 5, 10, 15, 20, so on. And in hex, you can do the same thing, but you can do it by 4s. So you can say 4, 8C, 10, 14, 18, 1C, 20, 24, 28, 20C, and then 30, and then 34, 38, 30C, and then 40, and so on like that. And the reason this works is, I mean, you can just try counting in hex and just take every fourth, and you'll realize that this works. And the reason counting by fours is going to be very useful is because one word is equal to 4 bytes. And so sometimes we're going to ask you to increment stuff in bytes. So, or sorry, we're going to ask you to increment stuff in words, but we're going to have stuff addressed by bytes. So sometimes it'll be very useful if I say, hey, can you jump 1 word forward? That's the same as jumping 4 bytes forward. So you'll want to be able to count by 4s. But again, I don't recommend doing this in your mind unless you feel very, very comfortable with it. And if you don't, or even if you do feel comfortable, I would say it is best just to pull up a hex calculator. There's no reason not to do it. Even on exams, we'll give you just very, very easy hex math, stuff that you can definitely just count one by one. And so just be very, very careful about doing hex math because it is pretty complicated and we don't expect you to know how to do it by hand.